refractive index of the lens is given. Okay, lens maker formula. For example, this is a lens, and this lens have two surfaces. Two surfaces are there. Okay, this is one surface, and this is another surface, and both the surfaces are the convex surfaces. Both the surfaces are the convex surfaces. This line is the principal axis. This line is the principal axis, and an object is placed here. An object is placed here. Now here are the two spherical surfaces. One spherical surface is this, another spherical surface is this. There are two spherical surfaces. One spherical surface is this, second spherical surface is this. As this is the object, so this object will give light. For example, suppose the light from this object is incident on the first. Okay, before that, we should know uh, for this surface, the radius of curvature, will be r1. Okay, and the center of curvature c1 will be here for the first surface, for this first surface, and for the second surface the center of curvature will be somewhere here, c2. Okay, and radius of curvature for the second surface. And remember one more point before that, this lens is a very thin lens. Lens is very thin lens. Okay, so this is the optical center. This is the optical center. I will represent optical center with C. Okay, so optical center. So this is R1. This distance is R1. Okay, so we will denote it later. So this is the object, and this is the first first surface. So object will give the light to the first surface like this. Okay, now this is the incident ray from the object, and we know that this, for this surface we will draw a normal. A normal will pass from the center of curvature of the first surface like this. This will be the normal. This will be the normal. And now refraction will take place, and the light ray will bend towards the normal. If you are considering this medium from where the light is, from which the light is coming, having the refractive index of n1 and refractive index of okay, so consider this medium, surrounding medium of the lens, having the refractive index of nm, and refractive index on the lens is n suffix l. So nm is the refractive index of surrounding. And nl is the refractive index of lens. Okay, so this is the normal. So this is the incident ray. For example, consider the light is going from rarer to the denser medium. This lens medium is somewhat denser medium. This lens medium is somewhat the denser medium. Lens medium is somewhat the denser medium. Okay, so light will go like this. With respect to this surface I am talking about, So light ray will go like this, and somewhere here the image will form with respect to this surface. But in between there is one this surface also, and this, and the boundary of this surface is separating the denser medium and the rarer medium. So from this to this surface, light is going from denser to the rarer medium. So we will draw the, and this is the second surface. This is the second surface. Okay, so you can draw. This is just the image formed. This is the I dash. Okay, this is I dash. I dash is the image formed when the object is here with respect to this surface. But in reality, what is there? This is the another surface. Light from this surface will bend towards the normal, and here the refraction will take place at this interface. So we will draw the normal for the second surface, because the refraction is now taking place from the second surface. So this is the second surface normal, second surface normal. This is suppose n1, this is n2. Okay, so okay.
Sir,
Hmm.
there won't be straight line in lens of that
Okay, okay.
incident line.
Hmm. This
Incident
one.
line in that lens straight line, that small.
Okay, okay. You are talking about this, I think. That one.
No, no. Like,
Mm-hmm.
is it? It's incidenting on lens, then straight line, then it will be.
Ha, you are right. You are right. You are right. But I have already told you, images formed when and when only at least two rays will meet. So you will just give one ray like this, na? So there will be one ray from the object like this. So here the image will form. Okay. So I am not showing here because you already know this point. Okay.
Oh, okay, sir.
This thing you were saying, na? Okay.
No, like in the lens
Mm-hmm.
अब जैसे
You can
लेंस
tell
में
in Hindi. You can tell in Hindi.
हाँ लेंस में जो ऊपर येलो लाइन है ना वो सीधा
Oh,
सीधा
actually,
बीच में
actually,
से स्ट्रेट लाइन आता है
you are right. You are not right actually. You
हम्म,
are saying that I should extend the incident ray like this. This na?
no in that lens only.
Hmm, what are you saying?
Okay,
Tell me,
wait.
tell me in Hindi once again.
uh, just
Mm-hmm.
next second में बताता
Hmm. Hmm.
हूँ। एक second। मेरा कैमरा पे है।
हाँ हाँ हाँ. Actually, ये blur blur आ रहा है फोटो.
इसको फोकस कैसे करूँ मैं?
हाँ हाँ, फोकस करो.
फोकस फोकस नहीं हो रहा है।
ट्राई करो. अच्छा हाँ, थोड़ा सा दिख रहा है मुझे वैसे.
हाँ इधर ऐसा ऐसा स्ट्रेट लाइन नहीं आता है।
हाँ, स्ट्रेट लाइन नहीं आएगा.
ओके।
एक्चुअली एक्चुअली उसका रीजन ये है कि स्ट्रेट लाइन आ भी सकता है और नहीं भी आ सकता है. इसके दो स्टेटमेंट हो सकते हैं. ठीक है. वो डिपेंड करेगा कि आपका एंगल ऑफ रिफ्रैक्शन क्या है. ठीक है.
ओके सर
वो
ओके।
डिपेंड करेगा कि आपका एंगल ऑफ रिफ्रैक्शन क्या है. जैसे कि मैं आपसे फॉर एग्जांपल इफ आई टेक दिस टाइप ऑफ लेंस, फॉर एग्जांपल if I am taking this lens, and suppose if an object is placed here, if an object is here, and for that particular position of the object, the incident ray is like this. The incident ray is like this, for example. Your question is quite good. Okay. uh, but in this case, this can be the special case. Okay, this can be the special case. Suppose here is the center of curvature c1 of first surface, and we will draw the normal. We will draw the normal. So if this angle is theta, if this angle is theta, suppose, now light ray will, suppose here is the rarer medium. So light is going from rarer to the denser medium of the lens. So light will bend toward the normal. So if the light will bend uh, like this, means straight like this. So it can be also true, but the for satisfying this condition, this will be only the specific case. Okay, this will be for only a particular value of theta. Understanding? This will be only a particular value of theta. Otherwise, all the time, there will be no straight line like this. Understanding? So there are the space. This can be one of the special cases. If the angle of incident is such that so that the angle of refraction is like this, then only it is possible. Otherwise, this is not possible. Generally, this case you will take. Okay. By the way. Okay. Now let's focus on this. So this is the object, and for this object from this surface, the image will be formed here when there is no this surface. When there is no this surface, when there is means there is the absence of this surface, then image is formed there. But in actual, there is this surface. So what will happen? Light ray will go like this. Light ray will go like this, and refraction will take place here. So as the light ray is going from now denser to the rarer medium, from here to here, light ray is going from denser to the rarer medium. It will bend away from the normal. Bend away from the normal means light ray will be uh, something like this, something like this, away from the normal. So away from the normal means away from the normal. So here the final image is formed. Here the final image is formed. Final image is formed here. Okay. Now all the distances we will measure from the optical center, and this lens is very thin. This lens is very thin lens. So marking all the distance, I am marking all the distance. Object distance, incident ray. The direction of the incident ray is this. This direction you will take positive direction. This direction you will take positive direction, and this direction you will take negative direction, because this is the direction of the incident ray. Okay. So if you are just finding out this distance, object distance, this. So this will be positive or negative. This will be negative because you are measuring this distance in the opposite direction of incident ray. So this you will take negative. Okay. This you will take negative. And if you are calculating R1, if you are calculating R1, okay, first we will use this in the formula. Okay, this is u, this is u, and what is R1? R1 is this distance between the optical center and the center of curvature is R1. But in actual, what is R1? R1 is the radius of curvature of this surface, means this distance will be the actual R1, but length is very thin. That is why I am saying the distance is R1. So this distance is R1, and you can say this distance is R2. This distance is u, this whole distance, and this distance is R2. I am writing what is R1 and what is R2. C and C1 is R1. C and C1 is R1. C and C2 is R2. C and O is U. C and O is U. And C and I is V. Ci is V. And Ci dash is the V dash. Ci dash is the V dash. This distance is the V dash distance. V dash. This distance is the V dash distance. This is R1. And this distance is the V. This distance is V. Distance between the center of curvature and the final image is formed. We have one formula, reflection from the spherical surface. When reflection from a spherical surface takes place, reflection from spherical surface take place, we have the formula n1 by v minus n2 by u is equal to n2 minus n1 divided by r. Now apply this formula for the first surface. So for the first surface, n1, I told you what is n1. N1 is the refractive index of medium from where n1 is the refractive index of the medium from where light is coming. Light is coming. And n2 is the refractive index of medium in which light is going. Light is going. So n1 will be, in this case, light is coming from this nm and going to nl. So n1 will be nm. Nm means refractive index of the surrounding medium. Refractive index of the surrounding medium. And n2 is refractive index n of lens. Refractive index of lens. And what will be v? For the first surface, v will be this v dash. Because for the first surface, the image is formed here. So v will be v dash. So what is v? V is equal to v dash. And what is u? U is u. Okay, u is u. U is u. Take u as negative, because you will take negative because that is in the opposite direction of actually just a minute. In this formula a sign is already taken of u and v, so we will put only u, but when there will be the values, then we will put those numerical values with sign. Okay, so now put in this formula, what is n1? N1 is nm. What is v? V is v dash minus what is n2? N2 is nl. What is U is U is equal to, and it will become nm minus nl divided by r1. Okay, you have to put r as r1, r as r1, so it will be r1. This is r1. Why I have put here r1? Because we will take the radius of curvature for the first surface, that is r1. R1 is the radius of curvature. I'm writing here, r1 is the radius of curvature for first surface, for first surface. R2 is the radius of curvature for second surface. Radius of curvature for the second surface. Okay. So this is the equation number 1. Now we will apply this formula for the second surface. For the second surface. So for second surface, apply what will be n1? Now n1 is the refractive index of the medium from where the light is coming. So light is coming this time from the lens medium and going to the this medium having the refractive index of nm. Means this time n1 is equal to nl. Just a minute. Actually, sorry. Here will be n2. I have done a mistake. Here will be n2 in this formula. Here will be n1 in this formula. That is why I was thinking that. So it will be changed little bit. There will be a little change only. Here will be nl. Here will be nm. So here it will also change. It will become nl minus nm. nm. Okay, for second surface, n1 becomes nl and n2 becomes nm. n2 is the refractive index of the medium in which the light is going. So light is going this time in nm medium. What is u here in this case? Now one important point here, for this surface, this v dash will be the virtual object. This I dash, not v dash, this I dash will be the virtual object. So v is equal to v dash, u is equal to v dash. So you can say I dash is virtual object for surface 2. Surface 2. What is v? V is v, because v is here. This is I, and this is the image finally formed with respect to the second surface. This will be v. And what is r? R is r2, the radius of curvature for the second surface. Now apply this formula. n2 by v minus n1 by u is equal to n2 minus n1 divided by r. Now n2 is nm. What is v? V dash means v, fine. What is n1? n1 is nl. And what is u? U is v dash is equal to nm minus nl divided by r2. This is equation number second. Equation number second. Now add equation number 1 and add equation number second. Add equation number 1 and add equation number second. Add both the equations. So this is equation number 1 and this is equation number second. So add both the equations. So adding equation 1 and equation 2. So when you will add equation 1 and equation 2, so what you will get? On adding, what you will do? Means you will add the left hand side of both the equation and add right hand side of both the equation. So when you will add the this is first equation. What is happening? Minus nm by 2 dash fine. Fine, fine. Adding both the equations. So what will we cancel out here? This thing will be cancelled out. This nl by v dash and nl by so this term and this term will be cancelled out. So you will have nm by v minus nm by u is equal to, here you will add this and this, so you will have nm minus nl divided by r2 plus nl minus nm divided by r1. Now nm you can take common, it will become 1 by v minus 1 by u. This is equal to, now you can take nm minus nl common, nm minus nl you can take common. So here you will have 1 upon r2 minus 1 upon r1, because when you will take nm minus nl common, so here will be negative 1. Okay, so after that you can write 1 upon v minus 1 upon u. This nm you can take this side, so it will become nm minus divided by nm, and this is multiplied by 1 upon 1 upon r2 minus 1 upon r1. Okay, when you will take minus sign common from this and this, so you will get 1 upon v minus 1 upon u. Just a minute, actually. Write this thing like this: nl by nm divided by r1 first, and then after that you should write r2. nm minus nl divided by r2. Now it's fine. So nm is common, it will be 1 by v minus 1 by u is equal to, now take nl minus nm common, nl minus nm common. and here you will have 1 upon r1 minus 1 upon r2. Now it will be 1 by b minus 1 by u is equal to nl minus nm divided by nm. It will be 1 upon r1 minus 1 upon r2. Now there is one formula, 1 upon v minus 1 upon u is equal to 1 upon f. This is the length formula. Length formula. So 1 upon v minus 1 upon u is equal to 1 by f. So we can put here 1 by f. 1 by f. This is equal to, you can divide this. So it will become nl divided by nm minus 1 multiplied by 1 upon r1 minus 1 upon r2. So this is the length maker's formula to calculate the focal length. What is NL? NL is the refractive index of the length. NM is the refractive index of the surrounding medium. R1 is the radius of curvature for the first surface. And how you will decide which surface will be the first surface? This can also be the first surface when the object will be placed here in this side. So you will decide the first surface, means the surface on which the incident light first is striking will be the first surface. Okay. So this is the length maker formula. F is the focal length of the F is the focal length of lens. F is the focal length of lens. So in this way you can derive. We have taken one lens, then we have taken one object, and from this object there is an incident ray of light, and after the refraction, the image is formed here. Okay. If there is, for this surface the image is formed here. Okay, but there is this surface, then here also the reflection will take place, then the image will formed here, and after that you have put all these things here. Now you have applied this formula for the first surface and the second surface, then you are getting equation number 1 and equation number 2, and after adding equation number 1 and equation number 2 you will get this form, and when you will again calculate, simplify this form, you will get this formula simply. Okay, Fawaz, and the understanding?
Yes, sir.
Okay. And remember, this formula is for valid only for the thin lenses. Only for the thin lenses. Okay, take the screenshot. Nida, completed. Nida, completed. Okay. Okay. Fawaz, done?
Yes, sir.
Okay. 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 Give me just 1 minute. This is the question. Find position, size, and nature of image formed by convex lens of focal length of 10 centimeter when a 2 centimeter long object is kept in front of the lens at a distance of 15 centimeter. So there is a lens, biconvex lens. I told you what is biconvex lens. This is a biconvex lens. Both surfaces of lens are convex. So this is a biconvex lens, and they are saying an object is placed at a distance of 15 centimeter. So this is the principal axis, and there is an object here placed at a distance of 15 centimeter. At a distance of 15 centimeter. The object is placed and height of the object is given as 2 centimeter. Height of the object is 2 centimeter. And they are saying kept in front of the lens. Mhm. 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 Focal length is 10 centimeter. Focal length of the lens is 10 centimeter. This is here in this question, the focal length is already given 10 centimeter. And this lens is a convex lens, so focal length will be plus 10 centimeter. For convex lens, the focal length is positive. Note down the focal length of convex lens for convex lens. Focal length is positive For concave lens, focal length is negative. For concave mirror also, the focal length is negative. Okay. We have the lens formula. One upon f is equal to 1 upon v minus 1 upon u. And they are asking the position. Position means they are asking v. Size means they are asking height of image. Nature means they are asking whether the image is real or virtual. So whenever it is asked in the question, what is the position, means you have to calculate image distance v. Whenever they are asking nature, means they are asking whether the image is real or virtual. And size means they are asking height of the image. Now we have the focal length of 10 centimeter, positive 10 centimeter. Object distance. Now object distance we will take negative or positive. This is the object. Neither tell me. We will take here object distance positive or negative. Negative. Very good. Why? Because the incident ray from the object will be in this direction. Okay, the incident ray. This is the object. So object will give the light in this direction. This is the incident light. So this direction will be the positive direction. Okay. And you are measuring the object distance from the optical center. Here will be optical center. So it will be in the negative direction. So u will be minus 15 centimeter. U will be minus 15 centimeter. So 1 upon 10 is equal to 1 upon v minus 1 upon minus 15. So it will be 1 upon 10 plus 1 upon 15 is equal to 1 upon v. Take the LCM. It will be 30. It will be 10 3 is 30 and 5 2 is 15 2 is 15 2 is no? It will be negative now. Like 10. It will be negative because this minus and this minus will become plus. So it will become 3 minus 2. 3 minus 2 is equal to 1 upon v. So it will become 1 upon v is equal to 1 upon 30. Finally, you will get image distance. V is plus 30 centimeter. And what is this plus sign indicating? Plus sign is indicating the image is formed at a distance of 30 centimeter from the pole, from the optical center in the direction of the incident light. So means image is formed somewhere on the right hand side. Somewhere here the image will form at a distance of 30 centimeter. Distance of 30 centimeter. Right now we do not know whether the image is inverted or whether the image is erect. Inverted and or erect. We don't know right now. Okay. So what we will do for that? There is a formula for the magnification. The next topic is the magnification. I will come to that. Okay. The magnification for the lens. Magnification for the lens is equal to height of the image divided by height of the object. One formula is this. Another formula is v by u only. V by u. So magnification we can find with v by u. So what is v? V is plus 30, u is minus 15. So it will be minus 2. So magnification is negative. So minus 2 is equal to, now we can use this formula, height of image by height of object. Height of image we want to find, height of object is 2 centimeter given. So height of the image is minus 4 centimeter. Now from this minus sign, you can say the image is formed below the principal axis, means image will be inverted image. Below the principal axis means the image will be inverted image. Image will be inverted image of a height of 4 centimeter. So if the image is inverted, so you can say it is real also. So nature of the image is real and inverted. Nature of image is real and inverted. Real and inverted. With the help of magnification also, we can tell whether the image is real or inverted. I will tell you later. Please note down, take the screenshots. Okay. Object distance is always negative. Huh. Object distance is always negative. Why the object distance is always negative? Because suppose you should means place the object anywhere. This is a lens, and if you are placing the object here, there can be the two condition. If you are placing the object here, and this is the optical center. Now, if the object will be here, so direction of incident light will be in this direction. So this direction you will consider positive, and object distance you will measure in this direction. So here the object distance is negative. Now if you are placing the object here, for example, you can place the object here also, na? So in this case, this is the object. So object will give the incident light in this direction. So this direction will be taken as positive direction. Now the thing is, you will measure the object distance from the optical center to the object, means in this direction you will measure the object distance. So means you are going in the opposite direction of the incident light. Here also, then object distance will be negative. So yes, we can say that object distance will always negative. Understanding? Okay, fine. I can think if the object distance is positive. Uh, okay, so it will be always. Okay, so please take the screenshot. After this, we will solve one numerical on the lens maker formula. Okay. Okay. They are saying find focal length. Find focal length. Number one. Okay. Pawal. Okay, take the screenshot. Okay. Hmm. Hmm. Okay. Find focal length. Number one. Biconvex lens is there. Biconvex lens. Biconvex lens having R1 is equal to R2 is equal to 10 centimeter, and refractive index of lens is 3 by 2. Okay. Lens is kept in air, and the lens is kept in air. So this is the first question. So we will solve first this. So a biconvex lens is there. So biconvex lens is this. This is the biconvex lens, and this is the principal axis. Okay, and R1 is this distance. This will be R1. This lens is very thin, na? So you can take the distance as R1, and you can take this is C1, this is C2. So you can take this as R2. Now R1 you will take, an object is placed here, this side. Object is placed. So this direction you will take positive direction. If this direction you will take positive, then R1 will be positive. Means R1 you will take plus 10 centimeter, and R2 you will take minus 10 centimeter. R2 you will take minus 10 centimeter. And refractive index of the lens, you have 3 by 2 means 1.5. And refractive index of the surrounding you have 1 because there is air surround the lens. Now apply the lens maker formula. Apply lens maker formula. So lens maker formula is 1 upon focal length of the lens is equal to refractive index of the lens, means n, refractive index of the lens divided by refractive index of the surrounding medium minus 1 is equal to 1 upon R1 minus 1 upon R2. Put all the values. 1 upon F is equal to refractive index of the lens is 1.5. Refractive index of the surrounding medium is 1. This is minus 1. And 1 upon R1 is 10 and R2 is minus 10. R2 is minus 10. Now you can find 1 upon F is equal to, this will become 0.5 by 1 multiplied by 1 upon 10 plus 1 by 10. So it will become 1 upon F. It will become 1 by 2 multiplied by 2 by 20. So this and this will be cancelled out. So focal length of the lens will be plus 20 centimeter. Plus 20 centimeter. Focal length of this lens will be plus 20 centimeter. Now, second question in this category is this. Hmm. This type of lens is given. Plano convex lens is given. Plano convex lens is given, and refractive index of the lens is 1.5, and surrounding it there is air, and radius of curvature of this surface is given, that is r1, or you can say r is given as 10 centimeter. Okay, 10 centimeter. So 10 centimeter is given. So what you will do, you have to find the focal length. You have to find the focal length of this focal length of this lens. You have to find. So for that, what you will do, suppose this is the principal axis, and what will be r1? So r1 will be this distance. This distance will be r1. This is r1, and you will measure r1 in this direction. An object is placed here. Object is here, so this direction will be the positive direction. Means r1 you will take plus 10. R1 you will take plus 10 centimeter. And now R2 for this surface. This is a plane surface. For the plane surface, the radius of curvature will be infinity. For plane surface, the radius of curvature is infinite. Okay. So all the values we have, now we will put all the values in the formula. Just uh, try to solve this question with this formula. 1 upon f is equal to refractive index of the, and I am writing here, refractive index of the lens is this, and refractive index of the surrounding is 1. Refractive index of the lens divided by refractive index of the surrounding minus 1, 1 upon r1 minus 1 upon r2. Tell me the answer. Solve it. If you don't know what is 1 upon infinity, so 1 upon infinity is 0. Okay, see, 1 upon f we want to find is equal to refractive index of the lens is 1.5, refractive index of the surrounding is 1, that is -1, is equal to 1 upon r1 is 1 by 10, and it is 1 by infinity. So 1 upon f, it will be 0.5, so you can write it 1 by 2, it will become 1 by 10. So focal length will become 10 to the 20, it will become 20 centimeter again. So now you can take the screenshot. Just a minute. Okay, now you can take. Okay. 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 Uh, Nida, I want to tell you one thing. You were saying will the object distance will always be negative. For the real object, the object distance will always be negative. But for the virtual but for the virtual object, there is virtual object also. For the virtual object, the object distance can be positive also. You can see here we have one virtual object, the lens maker formula. I told you that this I dash will be the virtual object for this lens. Okay, so there can be the condition in which there can be the conditions in which now if this I dash is the virtual object now, so but real object is this, so you have chosen the direction of incident light in this direction. Okay, so you will take this distance as positive distance. Okay. So that is true for the. Okay, completed now, Fawaz and Nida.
Yes, sir.
Okay, okay. So now we will discuss the magnification. Okay, magnification of lens. Magnification of lens. So magnification for the lens magnification. This magnification can be we will discuss the linear magnification. This linear magnification sometimes also known as transverse magnification. And there is one more name of this magnification: linear transverse lateral magnification. Lateral magnification. Linear transverse lateral means we are just calculating the length or the height of the image, length of the image, okay, or the object. We are considering the length of the or the linear dimension of the object and the image. So this linear magnification is represented by M. This magnification is represented by M, and this magnification is height of image divided by height of object. This is equal to height of image can be written as hi, height of object can be written as ho, and this is equal to v by u. This is for lens. We have all defined magnification for the mirror. For the mirror, the magnification was height of image divided by height of object is equal to minus v by u. So you have to remember the difference. You have to remember the difference between the two. Okay, now we will discuss what will happen when the magnification will be positive or magnification will be negative. So case number one, if the magnification is positive, magnification is positive means magnification is equal to height of image, height of object, means height of image and height of object should have the same sign, either positive or negative. So you can say hi and ho should have same sign, should have same sign. So what is the meaning of hi and ho having same sign? So this is the principal axis, and on this principal axis the object is placed like this. Means above the principal axis, if the object is placed, so this object height will be positive, means hi will be positive, height of object will be positive. If the image is like this will be also considered as positive, height of image I. So both have the positive sign, means the image is erect image or upright image. So you will say height of object and height of image will have same sign, the image will be erect, and erect image is virtual also. If the erect image is virtual also, means if the magnification is positive, then you can say, if the magnification is positive, then you can say image is virtual and erect. In case of lens, image is virtual and erect. Second case, when the magnification is negative. Magnification is negative. So magnification negative means magnification is equal to height of image divided by height of object. Negative means height of image and height of object should have opposite sign. Height of image and height of object should have opposite sign. Means if the magnification is -2, so when this -2 will be there, either you will write -4/2, there will be at least one minus sign. Okay, there will be at least one minus sign, then only now there will be here minus sign. So height of image and height of object should have opposite sign. What is the meaning of the opposite sign of height of object and height of image? For example, this is the principal axis, this is the principal axis, and one object is placed like this. This is the object. This object will be, height of this object will be considered as positive because this object is above principal axis. Above principal axis, the height of the object is considered as positive. So HI and HO should have opposite sign. Opposite sign means the image sign should be negative. Means image should be like this, below principal axis. So height of image is negative because this is below principal axis, this is above principal axis. Above principal axis. This is below principal axis. Below principal axis. So now you can see this image is inverted image. With respect to the object, this image is inverted. Okay. So if the image is inverted, it is real also? So now you can say if the magnification is negative, then image is real and inverted. Image is real and inverted. Okay. Fawaz understanding? And Nida? Okay, very good. Okay. 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 This chapter will over in the next class. in the next class. So just try this question by yourself. You have to apply this formula. In the next class, we will finish this chapter. Okay, so take this question as your homework. Take this question as your homework. You have to just apply this formula. This is a plane surface, and basically this is a plano concave lens. Plano concave lens. Understanding? This is plano concave lens. For this concave surface, the radius is given. And you know what is the radius of the plane surface? I told you infinity. So you will put the value, you will get the answer very easily. But you have to decide which will be the first surface and which will be the second surface accordingly. Okay, so Fawaz and Niza, we will meet in the next class.
Okay, sir. Sir,
And
what will